Welcome to Study Labs, and this is our demo number 10, in which I showed you some physics experiments and then discussed the phenomena behind them. And this demo number 10 is closely associated with our demo number 1, in which we had used our injection. And therefore, if you want, then you can always watch demo number 1 and first, and then you can come to this video if you want, right? So what we are going to do, we are going to see the effect of pressure on temperature. We know the relation P is directly proportional to T, that when pressure increases, the temperature will increase, and when pressure decreases, the temperature will decrease. And with this setup, we are going to discuss the phenomena inside a pressure cooker also. So what we have normal water, tap water, and we have a syringe and injection setup, and you have to be careful about two, three things. The first one is take less amount of water inside this, because you can take too much amount of water and still the phenomena will be there, but it is not quite visible, because now the heat has to heat up a large amount of water, and therefore the phenomena is not quite visible. So take less amount of water. Then if you are performing this experiment in winter seasons, heat up the water at least up to the room temperature, right? Not up to 100 degree, up to room temperature, because again, if water is at 4 degree 5 degree centigrade, the heat will again be there, but it is not, the effect will not be visible. So let's start our experiment, and I'm trying to take a little amount of water inside it. Okay, so I have it now. Focus on this black area, black piston, and let's see if you can see what the effect it creates. And I'm slowly pulling it, and you can see that the water is boiling up, right? I don't know whether the effect is clearly visible on the camera, but on the sides you can see that there are water droplets, and it is heating up, right? And even if you see the texture, there is a steam inside it. So water is boiling up, and maybe the camera is not quite good, but again, if you are experimenting it, you can see this phenomena by naked eyes. The water starts boiling up inside the injection, and why this happens? The pressure decreases, and therefore there is a vacuum inside this area, this volume, and therefore the temperature, the boiling point of water decreases, and it start boiling even at room temperature. So pressure decreases, temperature decreases. Now what's happening inside a pressure cooker? We close the container, and therefore we increase the pressure inside the pressure cooker, right? And if the outside pressure is 1 atmospheric, the inside pressure is 2 atmospheric, and therefore when we increase the pressure, the boiling point of water increases or rises up. In a normal pressure or 1 atmospheric pressure, the water boils up at 100 degrees centigrade, but inside the pressure cooker, the boiling point of water is 120 or 122 degrees centigrade. Now then you can correlate that if you put a potato, right, in 100 degrees centigrade water, and you put another potato in 120 degrees centigrade water, you can figure out that the potato in the second case will get cooked much faster, because it has a greater temperature. And therefore by increasing the pressure inside a pressure cooker, what we are doing, we are increasing the boiling point of water, and therefore the ingredients inside the pressure cooker get a much higher amount of temperature of water. So that's the phenomena behind pressure cooker. And maybe the camera of my mobile phone is not quite good, so you cannot see the phenomena clearly of water boiling, but with naked eyes, this is really cool to see. And you can see the water heating up and the bubbles going up, right? So thanks, and do watch my next upcoming demo session. Thank you.